So hi, here I just want to give a really brief example of a way to learn how a molecule is pH trapped. So let's look at aspirin. It's a weak acid. It could exist in the acidic form, that's on the left here, um, where the H is attached, right? So that's acidic form. Um, you can call that the ASACOOH form, ASA. COOH, that's a carboxylic acid form. Or it could ionize to give you the conjugate base. So that's a B, so that's the minus sign. So I call this the B minus form, okay? So that's a conjugate base, or it could be in the acidic form, the A form. And so the example I have is, if you think about you as a student, what grade do you want to get out of this class? You either want an A that helps you to be able to get to medical school or get a great transcript to get the best job, that your dream job, or do you want a B minus where indeed you're going to graduate from the university, but your grades are not that fantastic, so you may not be able to get to that dream professional school. So conjugate base is the B minus, and the A is the acid form. So that's the minus here, right? So now let's see how that can lead to a molecule being pH partitioned or ion trapped. So let's look at, for example, so this is in the A form, so that's the form. Now the thing about the A form is, note again the environment it's in. In this very acidic environment of the stomach, there's a lot of hydrogen ions. So I'm just going to put an increase in hydrogen ions. Okay, a lot of hydrogen ions here. Hydrogen ions, a lot of it. And so this reaction, this reversible reaction, favors this direction. So there's going to be more A form than there is B form. So A is a big A, and you might have a little bit of B, a teeny bit of B, because of the environment it's in the stomach, where there's a lot of hydrogen ions. So it shifts the direction of that ionization reaction. And so what's the consequence of this? Now, the A form, the unionized form, is able to cross membranes very, very rapidly. So if you think of the plasma as your med school, for example, the A form, the person who gets really A grades throughout, easily crosses the membrane. Think of the membrane as your MCAT, so M for membrane, M for MCAT, right? It easily crosses the MCAT, easily gets into medical school in that form, okay? However, let's see what happens to what happens once the environment changes. So let's assume, okay, let's just assume I use an antacid and I've changed the pH in the stomach to like a pH of 7.4, if that was possible, okay? I did some magic, took a lot of antacid, and now the pH is 7.4. What that does is now there is a lot less hydrogen ions, that the reverse reaction is what will be favored, okay? Because now the environment is very, very basic. And so now in such a scenario, you're going to have more of the B form, okay, the B minus form. Well, what happens to the B minus form is, notice what happens here. It tries to cross the membrane, but because it has a negative charge, guess what happens? The membrane repels it. So eventually your B gets to go down the gut, the stomach, all the way ultimately to become physical waste. So that's the example of somebody who indeed graduates out of GV or out of whatever university, but because of the environment the person is in, maybe friends that don't let them study, maybe partying or whatever, and so they end up having a instead of being in a nice acidic stomach environment, now they're in a very alkaline or basic environment. They just do the basics. They don't do any extra work. Just do the basics. So they end up getting a B minus, and guess what? They will graduate out of GV, but they won't have enough grades to be able to cross the membrane to go to their dream place. Okay, so that's just an example to help you remember. Now, the example I just gave of when you change the environment and it's now basic, that is what happens normally in the plasma. And so once the acid form has crossed the membrane, you can see that big arrow. What happens now is, because the environment is basic, meaning it has a lot of OH minus ions, guess what? OH minus ions and hydrogen ions become water. And so this reaction, forward reaction that ionizes aspirin to the basic form, to the B minus form, is preferred. And so once it's preferred, now a lot of the aspirin that started out as the A form is converted to the B minus form, and that form is unable to cross the membrane back into the stomach area. And so guess what? We say that aspirin is now pH trapped in the plasma, meaning it cannot go back to where it started from. Thank you. Just an example.